This episode is sponsored by Brilliant. Probably one of the most paradigm-shifting concepts leading into the modern era of science is that we are not special or terribly unique here on Earth, but merely one fairly humdrum species on a mediocre world among the countless trillions in the void. But what if that's the wrong perspective? So today we'll be looking at Boltzmann brains, the Anthropic Principle, the simulation hypothesis, and consciousness. This is part 2 of a collaboration with Jade from Up and Atom, so if you're coming over from her channel, welcome. And for channel regulars, you should watch part 1 on her channel first, where the Boltzmann brain gets explained, then watch this one, and you can find part 1 linked in the video description or the in-video card. Quick summary version though.
Improbable but possible events will tend to happen given enough time or space. Flip a coin enough times and you'll get heads 10 times in a row. Shuffle a deck of cards enough times and in spite of randomizing it each shuffle, you'll return it to some more ordered state eventually. Look at enough collections of matter and you'll find something that's randomly assembled into a seemingly artificial grouping, like the basic building blocks of proto-life, or a computer chip, or a brain, or even an entire galaxy. Needless to say, things which are more probable will be more likely to occur, and in Ludwig Boltzmann's time, the 19th century, we assumed that the universe was this eternal, infinite place where anything that could happen should happen, though again, the more likely it was to happen, the more often we'd see it. Thus, a randomly assembled brain would be more common than a randomly assembled galaxy, or a randomly assembled universe, which is a notion still often kicked around as a possible cause for our own universe appearing in a Big Bang, a low-entropy state slowly rising in entropy as the universe expands and decays. The thought that perhaps our universe simply emerged from some random fluctuation. Not very different than shuffling a deck of cards back into order, though vastly more improbable.
We examined this notion more in part 1, and our main interest now is in considering some of the possibilities it implies. To look at those, we first have to consider the Anthropic Principle, which is itself a fairly difficult concept to cover for a variety of reasons. First, it is a somewhat tricky concept. Second, the popular examples people use tend to really predispose people to dislike the solutions, and thus the method of reasoning. And third, there's no rigorous definition of what it is. In a way, it's not a tricky concept at all. It's basically the exact opposite of the Copernican or mediocrity principle, and is an example of a starting point you use for looking at situations when you have virtually no evidence to work with and no obvious way of getting more anytime soon. Its examples tend to include cases where it's basically impossible to get more data at this time, too, which results in examples that set many people's teeth on edge in my experience. What is the mediocrity principle? Well, you know that one. It's the cornerstone of science. If we have only one or only a few examples of something, we choose to assume they are pretty normal examples until we have evidence otherwise. Often they aren't normal, but it helps to start from this case. Hence we tend to assume Earth or humans are fairly common examples of habitable planets or technological civilizations. Hence the Copernican Principle. Earth is not the center of the universe and is probably fairly mundane or mediocre, and thus the generalized version, the mediocrity principle. Of course, often the first example of something we see is not particularly normal, and not just as an outlier of chance. That first alien you ever met was fairly tall or short for their species, for instance. Something watching Earth having come across it might catch our broadcasts of basketball games and assume humans were quite taller than our average. Frequently, the first example of something you're going to encounter is an outlier, not by chance, but for the reason you're encountering them first. This is how we ended up dubbing our sun a yellow dwarf originally, even though it's much brighter and more massive than average, because it is far easier to see the more massive and bright stars, so we thought they were normal first. What's more, you can have cases where simply by being able to observe something, you represent a skew on the normal. We're not talking about normal observer bias here, but the kind where your odds of being there to see something are altered by you existing. Now this often sounds a bit arcane, and many examples of it don't help, But you think about problems this way all the time, same as the mediocrity principle. You routinely encounter stuff and figure it's probably a mediocre and common example of that stuff till you get more examples. But you also assume you observing it is probably impacted by you. For instance, it's not going to surprise anyone watching this video if they go into the comments and see a lot of generally geeky comments on science, math, or science fiction. And you are probably watching this, observing this, because you have such interests too. You might be here randomly, but even then this probably got recommended to you because your prior watch and search habits indicated an interest along those lines, not a random observer, and it affected what you could see. Same, if you woke up with amnesia in a room full of people wearing the same clothes, you could assume via the mediocrity principle that most people wore that garb, like business suits or t-shirts and jeans for instance. Or you might assume you saw that first as an outlier appropriate to your observation, like doctors and nurses in scrubs as you had a head injury. Or you might glance down and notice you wore the same thing, like a jersey or military uniform. You banged your head doing drills, and you are observing them in this garb because you, as an observer, are just much more likely to be in their particular company. These are all valid approaches to looking at situations when you have virtually no evidence on hand. Now I mentioned that another problem with the Anthropic Principle is that it doesn't have an exact definition. One of the more famous thinkers on this topic, Nick Bostrom, noted around 30 fairly distinct versions when looking into the matter, and added his own too, the simulation hypothesis, one familiar already to channel regulars. Another, and the one where the term was first used, was Brandon Carter's Doomsday Argument, and this version often is called the weak Anthropic Principle, though he's since remarked that he wished he called it the Observer or Egocentric Principle instead. And as you've probably noticed, those are maybe better than the Anthropic Principle, since they more generally speak to what it is, an assumption when looking at a situation that you're not some random observer of an event that's probably normal or mediocre as such events go, but are focused more on why you are seeing that event. We looked at the Doomsday Argument some years back, and you can catch that episode for the details. The third well-known version is the fine-tuned universe theory, popularized by cosmologists John Barrow and Frank Tipler in their book The Anthropic Cosmological Principle, and along with the simulation hypothesis are all two of interest in regard to Boltzmann brains today. I mentioned that these examples often stir a bit of dislike and argument in folks when trying to learn the concept, and the reasons are pretty obvious. While the Doomsday Argument, simulation hypothesis, and fine-tuned universe theory are great examples for generating discussion of the topic, since they may be summed up in order as basically arguing humanity is mathematically doomed if reality is actually real, and if there is a God. Shockingly, these topics sometimes touch a nerve. For simulation hypothesis, the reasoning is pretty simple, and often misstated in discussion of it. Simulation hypothesis is not the idea that you might live in a false reality, but rather that you might live in a specific type, an ancestor simulation, which is where the simulators are specifically running their own history or a version of it. Like if we ran a simulation where a war ended differently or a piece of technology got invented sooner or later, or more personally, if your parents had moved to a different town when you were young, or so on. Those are ancestor simulations, and one of the reasons that distinction is important is because it implies the rules of your reality actually match up to the layer above simulating it. It's not very likely they'd have changed the basic rules of how the universe operated, or maybe at most tweaked one a little bit, and so studying the universe around you is actually helpful even though it's fake. Maybe the moon landings happened a decade later and by a different country, but the moon still orbits the Earth and for the same reasons. That's not a requirement of a simulation, and if you've played games where you can walk off one side of the screen and pop out the other, that's an example of playing with the basic physics. That universe circles around on itself and isn't a flat plane. More on that in a moment, and if you want more on the simulation hypothesis, we've got episodes looking at it, but one key bit of it is the principle of indifference. Yeah, lots of principles today. The principle of indifference, or principle of insufficient reason, is another of those approaches to making guesses and decisions when you basically know nothing. You assume if you have a handful of options, all reasonably plausible, but without anything to let you argue decisively that one is more likely than another, you just assume, for now, that they are equally likely. For the simulation hypothesis, we assume 3 reasonable scenarios. First, that nobody does the ancestor simulations because they are impossible, or you wipe yourself out before you can do them. Second, that nobody does them because they are impractical, or undesirable, or illegal, but that you can do them if you want. And third, that they can be done, and get done a lot. So much so that the vast majority of 21st century Earths are actually ancestor simulations run from some time ahead in the future. You'll often be told odds about us being a simulation or not, but by this reasoning it's 33%, or just under a third, because 1/3 is option 1, the other third is option 2, and in option 3, even if there are many more simulations than real universes, there's still a finite chance you're in the real deal, so just under a third. Obviously those 3 options aren't going to be equal in probability, but we have no way at this time of knowing what those odds actually are. Again, see those episodes for further discussion. This of course is not the only type of simulated universe you can do. You can change the fundamental physical rules, and presumably you could, for instance, set the speed of light in a simulated universe to any value higher or lower than what ours is. There being an awful lot of numbers, you basically have a vast number of unique potential universes you could generate this way, and there are other physical constants and parameters you could tweak too, either individually or in combination. Needless to say, there could also be a large number of other real universes with different physical properties too, one of the examples of the multiverse notion. As best as we can tell, currently, there is no particular reason why the physical constants of our universe are the values they are, so we assume they could have been different. And as best as we can tell, most of these values do not allow intelligent life to arise via evolution. Higher gravity, stars form and burn out too quickly for plants to have time for evolution, that sort of thing. If this is the case, that these constants can be over a huge range, the overwhelming majority of which can't have life in them, well, you've got a bit of a problem. The universe would seem to be fine-tuned for life. You can assume we just got lucky, or you can assume no such thing, that the universe is artificial, fine-tuned, divinely created or simulated, take your pick. The alternative is obvious by now, that this universe is indeed improbable, but that there are a bunch of other ones, not just ours, and most are indeed dead, but since nobody is there to observe them, their probability of existing is not puzzling anyone. There is no evidence supporting any of the options incidentally, and they're all pretty logically coherent, so feel free to pick the one that suits your tastes. It's very handy for discussing the concept of drawing conclusions and making decisions with very little data for that reason.
Now, this basic analysis of dead universes is off the notion of life evolving from something pretty simple into something much more complex. As we've noted, a Boltzmann brain is statistically far less probable in a universe with our characteristics than an evolving one should be. With other rules and probabilities, it's very easy to come up with a universe where, as improbable as a Boltzmann brain is, it's still more likely than Darwin's approach, because the latter just won't work there, whereas a Boltzmann brain could work pretty much anywhere. You could have a place where an entire universe blew into a supercomputer, and the machinery and fuel to run it evolved as soon as the place cooled down enough to operate. You could have one where gravity was just super weak and everything kind of meandered around in an aimless stew until eventually falling into patterns, and only those big and complex enough ones could really sustain themselves long enough to do anything. Even in some universe where gravity is so strong, virtually everything turns into black holes almost right away. The black holes could be used as a switch. You can create a computer that way, and so over a very long timeline, and black holes live for a very long time, you might expect a Boltzmann brain to emerge made out of things. Critical notion: these dead universes may outnumber universes like ours by so much that the number of universes in which one has popped up exceeds the ones where it evolved.
So such minds might be far more numerous than seemingly natural ones like ours. As we noted though, the simulation hypothesis only focuses on ancestral simulations because you can still meaningfully talk about the higher simulating layer if you assume it works on the same principles. Needless to say, some mind that just popped up out of nowhere, a new consciousness surrounded by the empty wastes of eternity, or living in utter sensory deprivation because it didn't come with any eyes or ears, is not going to be simulating us as an ancestral simulation. Even if it knows about the universe it lives in and the rules it has, which is hardly guaranteed, simulating 21st century Earth as part of its past clearly doesn't work logically. Which would seem to end the idea, except here we have some mind essentially dreaming away in the void. Possibly it's a more or less human mind, possibly it's some giant megacomputer like a Matryoshka brain. Either way, its sanity would seem rather dubious. We can't really assume that just because it was born blind and deaf and alone, it's naturally okay with those circumstances. We have a conscious mind shaped by evolution, presumably, so all of our abstract thinking has to make some sort of survival sense, and requires a certain basic level of sanity in one's natural environment for a given value of sanity. It does not. It did not evolve. It does not have any predators. But it has, by random luck, achieved consciousness.
Ponder that for a moment or two, and you can guess that this lone mind in the void is probably as mad as a hatter. If the randomly assembled brain was anything even vaguely like ours, which of course at least some would have to be by random luck, it would be very easy for something like that to dream up a reality. Either a world of people or just you. And indeed the just you option is a lot more likely since, as we noted at the beginning, a smaller Boltzmann brain, one just smart enough to be of human intellect, is way more probable than one that could do a whole simulated civilization or universe. Though it's worth noting, such a mind need not be static and incapable of growth just because it wasn't evolved. The random luck that created it probably needs to randomly give it fuel and repair options, or it'll be a pretty short-lived intellect, which might permit growth and mutation too.
Regardless, I doubt most of us really have to stretch our imagination too much to contemplate the notion that we might live in some world we dreamed up as a delusion. Incidentally, it doesn't actually matter that the rules of this universe would imply life was likely, since they'd presumably be self-rationalized anyway, or that the entire premise of this is based off assuming other universes exist that have different rules by having seen inconsistencies in our own, fine-tuning, because the premise doesn't come from that. Ignoring that it's an old idea, that we are dreaming reality, it requires no empirical evidence to assume your universe has rules, and that there may be other places with different rules. It merely requires you believe that there are rules to your reality, even if they are wrong or made up. Again, it's not an ancestral simulation, so we couldn't assume the real rules were anything like what we saw, but that hardly prevents us considering that there may be other places with different rules. In the broadest sense, if any place can exist, then you'd have places like our apparent reality where life evolved just like we think it did, ones where human-level minds, while improbable, popped out of nowhere first because evolution couldn't really work there, and ones where giant megaminds popped into being and dreamed us all up. Obviously hard to figure out which of these scenarios is more probable, but none should be impossible. So at the minimum, we can't rule out that there's a finite probability you or I are actually in any of these versions. Boltzmann brains dreaming up everyone and dreaming up rules too, without knowing either, or forcing yourself to forget things, which would require you be really nuts, like some sort of person left on their own in a dark prison cell for years. If you haven't already seen part 1, you can check that out for a discussion of why a Boltzmann brain, in spite of being very improbable in our universe compared to evolved intelligence, might be fairly probable or even more probable in a grand multiverse sense of things. Alternatively, we can't assume it is more probable anyway, since if we lived in one, or were one, our observations about this natural universe mean nothing anyway. Again, not an ancestor simulation. This, by the way, is why I often say the big question probably isn't whether or not reality is real, but if it actually matters if it is, or if we're just being a bit arbitrary about what real means. Anyway, the most probable Boltzmann brain would be a single simple intelligence, just one smart enough to think about such things as abstract concepts like this. And if you were one of those, then you'd have to assume we were made up voices in your head, and you'd have to be crazy to dream this stuff up, right? A theme we've had in today's episodes is that our common approach to modern science is to assume that all we witness is fairly random and ordinary, that our ability to absorb it is coincidental. We talked today about how that's not always the best approach, but it has generally been a very good way to go about learning how our world and the universe in general function, and that's been a very useful and profitable set of knowledge for humanity to acquire, as a group and individually. Understanding math and science is just plain handy, but it's also a lot of fun to know, and having fun while you learn it is also the best approach. If you want to learn more math and science, and have fun while you're doing it, try out Brilliant. Their online interactive math, science, and computer science courses and daily challenges let you enhance your knowledge of math and science with easy-to-learn interactive methods from the comfort of your own home and at your own pace. To make it even easier, Brilliant now lets you download any of their dozens of interactive courses through the mobile app, and you'll be able to solve fascinating problems in math, science, and computer science no matter where you are or how spotty your internet connection. If you'd like to learn more science, math, and computer science, go to brilliant.org/IsaacArthur and sign up for free. And also, the first 200 people that go to that link will get 20% off the annual premium subscription, so you can solve all the daily challenges in the archives and access dozens of problem-solving courses. We have our regular Thursday episode coming up, and for that we'll be back in the Alien Civilization series to take a look at the general methods and motivations for an alien invasion, be it overt or covert, and to try to reason why a hypothetical alien civ might or might not do such a thing in Invasive Aliens. Then we'll have our usual end-of-the-month livestream after to close out July, before heading into August to look at some examples of other threats to interplanetary or interstellar civilizations, from natural to artificial, internal or external, or existential. For alerts when those and other episodes come out, make sure to subscribe to the channel and hit the notifications bell. And if you enjoyed this episode, hit the like button and share it with others. And don't forget to check out Part 1 over on Jade's channel, Up and Atom, or any of her other awesome episodes. Until next time, thanks for watching, and have a great week.